guys, today we're going to be solving quadratic inequalities by graphing. So the key word here is that we're dealing with inequalities, so we're no longer having equal signs, but we're having greater than, less than or equal to, greater than or equal to symbols. So we're going to start by just graphing the quadratic. So I'm given a quadratic here in standard form, so I'm going to find my vertex to start by using x equals negative b over 2a. To get the x value, or the axis of symmetry. And here that becomes negative 3 over 2 times 1, or negative 3 halves. So that tells me I have the x value there. It's going to be over here in between, and that's okay. Then we're going to find what the y value is at that value. So it's going to be negative 3 halves squared plus 3 times negative 3 halves, and then minus 4. From there, we're going to solve it, and this becomes 9/4 plus negative 9 halves minus 4. Here, I'm going to rewrite this and make it have a common denominator. So I'm going to multiply this by 2 and that by 2, so I can combine them a little bit nicer. 9/4 plus negative 18/4 minus 4. So this gives me negative 9/4 minus 4, which I'm also going to have the common denominator by multiplying the numerator and denominator by 4. So that becomes 16 over 4, and that is equal to negative 25/4. And negative 25/4 as a mixed number is going to give us 8 and 1/4. So we make a table. Our vertex is going to be negative 3 halves that. Except Ms. Marshall messed up. That should be negative 6.25 instead of 8. So let's just keep rolling. I am going to get some other values. So let's go to negative 2, negative 3, negative 1, 0. So the cool thing about having 0 here, that's our y-intercept. So our y-intercept is always the c value. So that's negative 4, that's negative 4. I'm going to substitute in negative 1 to find what this value is. So that ends up being 1 minus 3 minus 4. So 1 minus 3 minus 4 is going to give us a negative 6. And there's my points. So let's graph this. Negative 3 halves, 1, 2, 3, 4, 5, 6. And a little bit there. It's not completely accurate because it's a small space, but that's okay. We're getting the idea down. Negative 2, negative 6, negative 1, negative 6. And then we're also at our y-intercept of negative 4 here and there as well. So now we can start to draw this line. Before I draw this line, I do want to note something that hopefully you remember from doing this with linear equations, is that we don't have an equal to line. So no equal to line tells us that we're going to use a dashed line. So I'm going to do some dashes for my parabola, and I'm going to bring them all the way up. If you wanted to get more points to make sure your parabola is a little bit more accurate, that's okay. And next, we need to figure out shading, whether we're going to be shading here for our solution set, or we're going to be shading on the outside for our solution set. To be able to figure out where we're going to be shading, I'm going to pick a tester point. So my tester point, if I pick something inside here and it's true, that means I shade inside. If I pick a tester point on the outside and it's true, I shade the outside. But if I pick a tester point on the inside and it's not true, then I shade the outside. If I pick a tester point on the outside that's not true, I shade the inside. So let's pick a tester point. I always like to pick the tester point 0, 0 if it is an option, because it's nice to substitute into an equation. So the tester point 0, 0, I substitute in 0 for my x value and 0 for my y value. So 0 is greater than 0 squared plus 3 times 0 minus 4. 0, 0, and negative 4. And it says 0 is greater than negative 4. That is true. So I'm going to shade the zone where my tester point is, because that gives us a true statement. So a little bit of information about your tester point. Always pick a tester point that's entirely on the inside or entirely on the outside of your parabola, because if you pick something on the line, it's just going to reflect if it's a solid or dashed line. So if I picked this point right here, my vertex, my not my vertex, my y-intercept 0, 4, that would be not true because it's not an equal to line. If there was an equal to line, it would be true. Hey guys, Ms. Marshall from the future here. So I don't think I did a good enough job explaining, just making sure it's clarified that everything in the shaded region, every single ordered pair in this shaded region is a solution to this equation. And the reason it's an ordered pair is the solution is because we have an x and a y. This point out here is not a solution because it's not in the shaded region. As I mentioned here, anything on this line is not going to be a solution because it is a dashed line. If it was a solid line, it would be a solution. So just to give you a quick example, this point right there, since it's in the shaded region, is a solution. It makes this equation true. Okay, Miss Marshall from the future out. So we're going to move on to this next one and graph it and find our solution set. So for this next one, we are going to start by graphing it. And this technically standard form, but it's also technically vertex form, because your h value is 0. So my vertex automatically is going to be 0, 4. And it's also my y-intercept. So I'm going to go 1, 2, 3, 4. And put a point for my vertex. And then my a value is negative 1. So I'm just going to follow the pattern to graph it very quickly. So down 1 over 1, down 3 over 1, down 3 over 1. You could have used a table to help you graph that, but I'm going to leave it like that. And then I'm going to draw a solid line because we have an equal to line. And I'm going to extend it down each way. And then I need to pick a tester point to figure out where I'm shading. 0, 0 is still a good option because it's completely contained on one side or the other side of the line. So 0, 0, it becomes 0 is less than or equal to negative 0 squared plus 4, or 0 is less than or equal to 4, which is true. So since that is true, I shade where 0, 0 is, and since it's on this side, I shade again on the inside of my graph. And while this did happen for these two examples, it's not always going to happen where you shade on the inside, so to say, of your parabola. So I just kind of want to go through and run through your steps to graphing a quadratic inequality. So step 1 is graph it. Pick solid or dashed line, depending on if it's an equal to or not equal to inequality. Then you're going to pick a tester point that's not on the line. 0, 0, as I said, is always a good option. And then you're going to shade according to your tester point. So there are some steps to kind of help you guys out. So I have 3 problems here, not on that back, but here. They are on the back of your sheet if you print double-sided. And I would like you guys to try these on your own. So I'm going to go over them once you guys try them. This is going to really have you guys review your different graphing because you've got intercept form. This is technically standard or vertex. You can kind of think about it in both ways. And this is your vertex form. So give it a go. Pick your tester points. And I'm actually going to add an equal to line for this one because there are no equal to lines, and that should already show up on your paper because I'm going to edit it before I put it into Schoology. So pause the video here and give it a go. Okay, so for this first one, you found it was an intercept form, so you had your zeros, -3 and 1. You could find your vertex by finding the average between them and then substituting that point back into the inequality. So your vertex is -1, 2. You pick some points before and after it. And so I was a little bit silly. So I know I needed to figure out what these 2 points were. So I started with 0. I got that 0 was 1.5. So using this property of symmetry, I knew that -2 is also 1.5. And then I started to do the same thing with x equals 1. And I wrote duh because, of course, 1 is 0 because it is a 0. So silly me. But I've graphed it there. I use a dashed line because I don't have an equal to line. Here, my tester point was 0, 0. It was on the inside. If I substitute it in, I get 0 is less than or equal to -1/2 times 3 times -1, which is 1.5. 0 is less than 1.5, which is true. So yet another one where I shade on the inside of the parabola. For the next one, there's a few things I did with this one just to kind of show you. Well, you can get your vertex because your h value is 0, so it's 0, -9 for your vertex. Your a value is 1. I also wanted to show you that you can also get the zeros from this pretty quickly because it is a difference of squares. So this tells you that you've got 3 and -3 as your zeros. So I ended up doing a few extra points to kind of put it together. And since our a value is 1, when I put my vertex, I just went up 1 over 1, up 3 over 1, and then I added the 0 points that I put in there. There's a solid line because I have the equal to line. My tester point was 0, 0 yet again because it's a solid tester point when it's not on the line. And I got 0 is greater than or equal to 0 minus 9. 0 is greater than -9, which is true. Whew, you're going to find that throughout today is me picking 0, 0 as a tester point. It ended up being true every single time. That's poor example choosing, Miss Marshall. And here you end up shading on the inside. For this last one, I got my vertex from vertex form. My a value was 3. So I put my vertex down, -2, 9. And then I counted up 1, 2, 3 over 1. And then I kind of did this in my head. I counted up and found what my y-intercept was and put the other point. You might need to write that down, or you can continue with the pattern. I do want to mention that we could not do that up here. We could not do the over. Technically, you can do over 1/2, but it gets really complicated because you can't keep counting it out. So I don't suggest you do the count out. I suggest you use the point for when you have a fractional a value that is less than 1. And then I picked a tester point. My 0, 0 is just on the outside of my parabola. And it ended up being true. So I shaded on the outside this time because that's where my tester point was. Let's just kind of entertain ourselves a little bit and say if we picked the tester point -2, 0, which is right there. And I substituted it in, I would get 0 is less than or equal to 3 times -2 plus 2 squared minus 9. This ends up being 0 because it's this -2 plus 2 times 3. It's still 0. 0 is less than -9. That's not true, which is why we don't shade on the inside. So that kind of gives you that other scenario that Miss Marshall didn't cover by choosing poor examples. Otherwise, that's all we have for today. If you have any questions, make sure you ask them and enjoy yourselves. Bye-bye.